Hey, it's Dave in the shop, and today we're going to talk about Meshtastic performance. These little radios, they are great for messaging, and certainly in a off-the-grid kind of situation where you're not depending on cell towers or other infrastructure, so it's a peer-to-peer mesh network setup. However, they come with a little antenna that sucks. These antennas, it's not really an antenna. What I'm going to do is show you how you can build a low-cost, high-quality, well-performing antenna to put on this radio and be able to get much better results out of it. So I use a little radio like this in my attic, and I have an antenna that's made out of just copper wire and a little connector, and that makes a huge difference in performance. I'm going to show you how to make this little antenna. Stay tuned. Now let's talk about the materials that you're going to need to make this antenna. So the wire that we're using, this is 12 gauge copper wire that is got insulation on it. I have an old spool of it that I've had for years, and we need a connector, and I'm going to use a little pigtail with an SMA connector on it, and we'll solder that on to the antenna at the feed point. So the tools that we'll need for this project is going to be a soldering iron. I've got my Weller little soldering iron, nothing special. We're going to need some cutters. I've got a nice pair that cuts off the wire very square. We're going to need a utility knife. I need that to be able to strip the insulation off of the wires. And we need the ability to measure. And to stabilize the antenna when it's finished, I use a little dab of hot glue. So hot glue gun is handy. Not necessary, but you'll get better results with that. A couple of other tools. You need some little pliers. In this case, I've got one set that is flat blade little pliers. These are great for just straightening, working the metal and straightening it out. The other is a pair of pliers that have round tips on them, very small round tips. And that's it. I mean, it's a very simple set of tools that's needed, and pretty easy design if you follow a few of the key tips. Okay, the first step in making this antenna is I need some wire. I need about 3 feet of wire to make the entire antenna. There'll be a little bit left over. So let's roll out and measure out about 3 feet. And there we go. All right, so we got our 3 feet of wire. Now the next step is I want to remove the insulation. And I try to also straighten the wire as much as I can, just pulling it. I mean, there's a lot of different ways to do it, but I get pretty decent results doing it this way. Now, to remove the insulation, my trick, if you want to call it that, is I'm going to grab the wire here. I'm going to use the table and my knife to try to get as parallel to it as I can. And then I'm just going to pull it through, and you see that insulation coming right off. Boom, there we go. That can go in the trash. And then, let's see, I missed a little spot on the end, so we'll grab that on there. And then the part where I was holding it, let's strip that off of there. Boom, there we go. Now I can just peel that insulation right off without having to bend my wire up too much. Okay, that's good. So now what I really just want to do is take my time, be patient, and try to straighten it out as best as possible. Now I will have dimensions attached to this project, so you can look in the notes and be able to look up and get the measurements to use. Key thing when we're working in, especially in these high frequencies, you know, this is for the 915 megahertz band. Accurate measurement is super important. So take your time, go slow, measure accurately, and then the antenna will perform well. Let me explain what this antenna is and how it works. This is called a Colinear antenna. So what we have is a half-wave antenna on the top and a half-wave antenna on the bottom. And then there is this little tuning section that it's an impedance adjustment section. So what this does is it takes the impedance for the end of these two antennas, which is very high, and we use this little section to bring it down to 50 ohms, which is what your Meshtastic radio wants to use. In fact, that's pretty standard. Most all radios are set up to use 50 ohms, and you certainly could make this for different impedances by sliding where this is connected, sliding it up and down to change the impedance. So what we're going to do is we're going to cut a length of wire to make this driven element. So if I look at each side of this, it's about 6.5 inches. So let's call that 7 inches. That's 14 inches there. Then we've got the tuning stub piece, and that's about 3 inches plus a little more. Let's call that 7 inches of material, 7 inches of material, 7 inches of material, 3 times 7, 21. To measure out 21 inches. And we will cut it right there. Okay, so now we've got the material needed to make the driven element. This remaining material, we're going to save it and use it as a support to hold the antenna out away from whatever you're going to mount it on. So it's just a really cheap and easy way. If you notice, mine has a stub on it, and then I bent this so that literally in my attic I've got 2x4s that are vertical 2x4s. I just clamp it onto that 2x4, and I've got a little clamp on shelf that holds my radio, and this connects in with a little piece of feed line. And one other tool that's handy is a Sharpie, so that I can mark the center location of the antenna. So 21 inches, so we'll go to the 10.5 inch point and make a little mark. Go to the center point, and we're going to work and bend this to 90 degrees. And the key in making this tuning section work is I want the spacing between these two elements to be about 1 diameter's width of the wire that I'm using. So as you can tell, that's going to be a very, very sharp bend. So I just have to be patient and work it. I use my little flat blade pliers to get that, and then they're small enough that the tip of them is about 1 width. And so then I get my my small bend. Now what I've got to do is work this to make that parallel all the way down. So I'll just take my time, do a little bit of adjustment here, get the center part done well, and then again, this is kind of where the flat blade comes in to help it be straight and even. You want that distance to be the same all the way through. And as what you'll probably notice is, you know, it's wiggling around out on the outside. And that's where the hot glue comes in, is once I've done and I've got the spacing just like I like it, I will put a little dab of hot glue just to hold the antenna elements in place. And hot glue is a good dielectric material, so it really doesn't upset the performance of the antenna. And that'll stabilize that. And again, this antenna, the way we're building it with these materials, you can put it outside. You need to be kind of careful with it, and you know, it could get damaged by a falling limb or something like that. But again, it's super cheap, so it's really easy to replace. But I use mine in the attic. I get it up as high as I can possibly get it in the attic. And my house is 3 stories tall, and the attic is the 4th story. So, and I live kind of on high ground, so I get very, very good coverage. I'm, you know, hitting repeaters that are 40 miles away with this setup. So, you know, it can work very well. Just get it high up as you possibly can. That's the most important thing, right? Good antenna, very short feed line, high as you can get it. All right, let's continue to work through this. We'll just get our spacing just like we want it, and that looks pretty good. Now the next piece of this is I want to get the bend for each radial going up, right? So these radials will start off being a little bit longer than need be, and we'll cut those down to tune the antenna to the desired frequency. So let's use our handy marker. And what I'm going to do, if I look at the measurement of that, is about 75 millimeters to from the antenna element, center point of the antenna element, to the back of the stub. So that's what I want to do with my measurement. So I will make a little mark on each element to represent where the bend is going to go. Just double check that, make sure it's right. Measure twice. Bend once. All right, so now this is where these little flat blade really come in handy. So I'll line those up on my marks. And then I want to do a very tight bend, as tight as you can make it, as tight a 90 degree. All right, I got my bend. It's right on the marks. I've got my separation, and I'll take the pliers and clean that up just a little bit, really get that just right before I glue it down. All right, so now I've got a colinear, you know, there are 2 antennas that will be in phase and matched, and one up and one down. So now the next step on this is to cut this antenna to length. And I want to again make sure that my measurement is exactly right. You know, I'll have a measured drawing for you to work with. And probably the easiest way to do it is I put my ruler up against that bend, right? And if I look at it, that is 162 millimeters. So I'll do the exact same thing here. (162 millimeters). Same on both sides. And now what we'll do is we will cut these two elements to length. Again, try to be as precise as you possibly can. All right. And then since I have one already, I match it up, and yep, it's basically exact. All right, so that's the driven element component. And then what we'll do is we'll take our leftover material and we're going to solder it in on the back of this stub. And I know that, you know, one thing is you'll have to be careful with it. I've soldered in, you can see on the stub, and then over here I have to solder to the material. So what I've done in the past is jigged it up so everything held in place, and that makes it real easy. But that's kind of the only key thing. The nice thing about this is a at the bottom of this is the equivalent of ground. So it's this type of driven element can be mounted against a ground plane. It can be soldered right in. It could be, you know, mounted to a pole right at that point. But in my case, in the attic, I just want to get it away from everything, so I put this extension on it. So you want to be several wavelengths, ideally away from anything metal. Will give you the best performance. And of course, a easy way to think of it is end to end of this, that's about one wavelength. So you want to make sure that your antenna is that distance, maybe further, away from metal. Now in my case, where I'm mounting it to wood, I just use a clamp to clamp this against the 2x4, and that works just great. Now the next step is to solder the long piece of wire onto the antenna. And what I've done is just taken this piece of scrap steel plate and a few magnets just to kind of jig it up and hold it in place. I'm going to put just a little touch of flux on it to help that. And get our soldering iron cleaned and ready to go. So let's apply heat. Let this get good and hot. Okay, we'll let that cool. Now the next piece we need to do is to take the
the little pigtail that's got our connector on it. And if you can see, it's been trimmed back. The outer jacket's been trimmed back, and the shield is exposed. This shield has been tinned already, the way I bought it. And there's a little bit of dielectric, and then the center conductor that's sticking out. What we're going to do is we're going to solder the center conductor onto one side of the tuning stub, and then solder the shield to the other side. I like to start by doing the center conductor, because then that helps me hold it precisely in place while I solder on the shield. So what we want to do is measure out from the very back of the stub 15 millimeters. And that's going to be our connection point. Okay, we got a little small mark on there. Now let's tin it. Just so we have a good spot for the center conductor to connect. And then we're going to tin the other side. Get that solder. And that's where our shield will connect. All right, so now we're going to solder that center conductor in place. And that should have that. And now we're going to solder the shield in place. We'll get a little bit of solder on each side of it. A little bit of buildup. That should hold it in place nicely. Let it cool. All right, so there we have it. Our feed line is soldered on. We'll be able to wire tie this back up right here. And you can see we're about 20% of the way up the stub. And that tends to make a nice impedance match for around 50 ohms. If we needed it to be 75 ohms, we could move it out just a little bit, and that would raise the impedance. If we needed to go a little lower, slide it back. All right, there we go. All right, antenna is looking good. Now the next step on this is what we want to do is a little bit of measurement. So I'm going to go get my tiny VNA and hook that up and check the resonance on this antenna. All right, I've got my antenna in the vise here, so we're a good ways away from metal objects, and I'm using my nano VNA device. And let me pull up my settings, get those configured correctly. All right, there we have it. My marker set for 912 megahertz, and you can see the SWR, the big dip for the resonance on it. What I did, having the VNA, I was able to really fine tune it just by squeezing in and out that that tuning stub a little bit, and then that just brought it right onto perfect resonance and matched it up very nicely. So the next step on this is I will fire up the hot glue gun, and I'll put just a little bit of hot glue right on the end to hold that stub in place, and then basically we're finished. All right, so that's it. That is the Colinear antenna, and it's all tuned and everything works good. Now I've got this piece of wire back here that can be used as a mounting point, so depending on what you need to do, you can drill a hole in something and stick it through there, or you can bend it in a little loop or whatever to use a clamp on it to hold it in place, and then connect up a short piece of feed line, however long it needs to be, to get to your radio, however you mount that. But you put that in the attic, put it as high as it can go, and that's a really good antenna. That's just gonna, beat the heck out of the little stubby antennas that come with the radio. There's longer rubber ducky style antennas that are better than this, but they're not better than this. This is really hard to beat. This has got nice gain to it. It's got a beautiful pattern on it, and it's so simple and so cheap and easy to build. I hope you enjoyed this build video. Please remember to like and subscribe. That helps the channel get out there and more people able to see it and take advantage of it. This is Dave in the shop.